In today's session, we are going to see about 3D transformation. What is transformation? It is a fundamental part of the computer graphics and it deals with moving of the object on the Cartesian plane. So here the Cartesian plane is XY plane and the object here gets transformed. That is, the transformations can be performed on this object. There are two types of transformation. One is 2D transformation, that is two-dimensional transformation, and the other is three-dimensional transformation. And the transformations that can be performed on 2D and 3D are translation, rotation, scaling, shearing, and mirror reflection. Why we use transformation? Transformations are used to position the objects, to shape the object, to change viewing positions, and even how something is viewed. For all these things we use transformations. Simply, if we want to say, the transformations are used for modeling and viewing. That is, in simulation purpose we are going for transformation, and viewing we are going for transformation. 3D transformation. What is 3D transformation? If the transformations applied on 3D plane, that is x-axis, y-axis and z-axis plane, then it is called as 3D transformation. And in 2D transformation we will be having only two axes called x-axis and y-axis, on which z coordinate to be included straightforward for performing some transformations called as translation and scaling in 3D, which is easier, but in the case of rotation it is somewhat difficult. Homogeneous coordinates, that is, there are four components to be considered for homogeneous coordinates in 3D transformation. They are x-axis coordinate x, y-axis coordinate y, z-axis coordinate z, and h is the homogeneous coordinate. Since there are four components in this homogeneous coordinates, we are having a transformation matrix of about 4 cross 4 elements, that is 4 cross 4 matrix we are having here, and here represents some values of 4 cross 4 matrix, which is Tx, Ty, Tz, which is transformations on x, y and z axis, and 1 is the homogeneous coordinate. 3D coordinate system consists of 3 axes that is being represented here, and point is nothing but 3 axes is x, y and z coordinate is being represented in a column wise manner, then it is called as a point. Then what is 3D point? Homogeneous coordinate. Whenever I come for homogeneous coordinate, it has 4 components. So what I have to do? I have to go with x, y, z and 1. So 1 is the homogeneous coordinate. So representing that in a column wise is the 3D point homogeneous coordinate. Normal point is representing the axis in the column manner, and 3D point is nothing but what? Along with homogeneous coordinate, if they ask, you have to write x, y, z and 1. Now, next comes why homogeneous coordinate. It is easy to compose translation and rotation. It is easy to compose translations and rotation. The first topic under your 3D transformation is 3D translation. What is translation? Let me consider an object. This is the object at position P. So here it is at the position P. I am going to move the object to the position P dash. So at this position the object has its own coordinate value x, y and z. After moving this object from P to P dash, what happens? Its x value, y value and z value gets changed. That is what it has been mentioned as x dash, y dash and z dash. Some translation distance has been carried out. From this point to this point I am moving that, right? So this is what the distance, and it has been represented as Tx, Ty and Tz, which may take any real value. So this is the translation distance. So from P I am going to move the object to P dash. At P, the object has x, y, z coordinate value. After moving it to P dash, the object has x dash, y dash, z dash value. So how can I write this? So P dash is the new position. On applying some translation over that position, I will be getting a new P dash, that is position. And here P dash's coordinate values, homogeneous coordinates are x dash, y dash, z dash and 1. And the transformation distance are represented with 4 cross 4 matrix. And P has its original value, say x, y, z and 1. This is what the representation. Now, coming to the matrix representation in 3 equations. Then what is x dash? That is newly formed x dash has been obtained by some translations on the x-axis along with the original value, adding with the original value. Like that, 3 equations are formed. Tx, Ty, Tz consist of real values, any real values. So specifying translation distance, it is the translation distance which may take any real value. Translation object here means which is equal to translating each vertex in the object. So which means that an object is transformed means what it means actually, every vertex of the object gets also transformed. So that is what translate object is equal to translating each vertex in the object. So we have to see about 3D rotation, scaling, reflection, shearing. That we'll see in the next video. Thank you.